Okay, now that we know a little bit more with regards to what is electric circuit, what is a resistor, what does it mean when I talk about series and parallel, what is measuring potential difference and current, now I can go and look at the steps that I want me to explain. Okay, the first step says identify a problem and develop a question. What is it you want to find out? So what you are going to do for your portfolio of evidence, you are going to copy step 1. You're going to say step 1 says identify a problem and develop a question. What it is that you found out. Okay, so what would be the problem? And what would be the question? Okay, if you go and read your experiment, it says electric circuits and with resistors in series and parallel, measuring potential difference and current. In other words, your question is, will there be a difference between your potential difference in your current, or will there be a difference in your current and your resistance when it is compared with series and parallel? In other words, what is the difference or what is the comparison between circuits in series and circuits in parallel? That is your problem. That's your question. What is the difference? Step 2, ask form a hypothesis. What is a hypothesis? A hypothesis is a question you ask. Let's ask a question that is applicable to today. Lockdown. The hypothesis says lockdown may decrease the COVID-19 to be spread. Okay, in other words, us staying home. That's the hypothesis. Now they are doing all of this experiment. They're looking at the graphs. They're seeing if it's working. And now they're saying, yes, the evidence shows that indeed lockdown, staying at home, decreases the spread of the COVID-19. Therefore, the hypothesis becomes a fact, a medical rule, and we will accept it like that. Okay? So can you see what I did? I made a prediction. I said the lockdown, staying at home, what will it do? It will decrease the spread of the COVID-19. Okay? So now your prediction can be something that we've just looked at. We can say, when resistors are placed in series, it will increase the total resistance of the circuit. But as the resistors in the circuit increase, it will also let the current decrease. Can you see my hypothesis? That is, in other words, my prediction. Now, let's look at the prediction for parallel. Look at the words I'm choosing. Hypothesis doesn't say it is the way it is. It says it may or if. Okay, so let's say if resistors are placed in parallel, it will decrease the total resistance of the circuit, and that will then increase the current. Can you see? Now, that is my experiment. I said what I think is my problem. I'm comparing parallel to series in step 1. In step 2, I'm formulating a hypothesis saying, what am I looking at? In step 3, I'm actually doing that. Okay? So let's take COVID-19 again as an example. I'm identifying the problem. The problem is COVID-19 is spreading because of social interaction. That's my problem. My hypothesis says if I can decrease social distancing and I can make sure people stay at home, it might decrease my chances of catching COVID-19. Now, step 3 is going to do it. Let's stay at home. Let's see what happens over 2, 3, 4 weeks from now. Can you see? We are actually busy doing a experiment while staying at home. Okay, can you see how I'm also encouraging you to think scientifically? Okay, now step 3, coming back to our portfolio. Design an activity or an experiment to do something that will help you test your idea. Now, this will be something like actually building a little circuit. For instance, you need to go and look on the internet. I don't want to give you all the answers. Go look, there's wonderful assignments that you can do with classes. Remember, this is a grade 10. They told you it's grade 10, so make it applicable. So go and do research. Type in Google. Say there, circuit experiments to show the comparison between series and parallel. So then you need to design that. So explaining step 3 what you're going to do. Okay, step 4 is going to observe. You are going to do the experiment and you're going to make a record of your observations on a table, for instance. Okay, so you're going to do it like almost like I've done what I've sent to you now. You're going to say, okay, the current, this is what happened. The resistance, this is what happened. So it's going to look a little bit like this without the voltage. You're going to say you've got your series. What happened to the current? What happened to the resistance? What happened to the current? What happened to the resistance? Again, I'm taking COVID-19 as an example. We're observing. How are we observing? They are constantly applying us or they're giving us the numbers across the world, and we're looking at countries that already went through the lockdown. We're interpreting it through graphs. So we are observing, like let's say for instance, if you go on the Worldometer for COVID-19, you will see that the graph shows in certain countries during the lockdown the spread of the virus decreased, for instance. Can you see it's going to be the same here? You're going to make an observation by, let's say you take notes. Okay, now this is obviously not going to be done in class because you're not in class, but you can now make use of virtual experiments like we studied on the internet, on YouTube. There's nice little videos that you can look at and see what is going to happen. Is the light going to dim brighter? Is it going to be dim, or is it going to go brighter when it's in parallel or series? Make that and write about what happened. Okay, so obviously you can most now make your own assumptions with regards, even if you don't have watching the video. I've said enough that so you can make your own assumptions. Step 5, make inferences about the observation recorded in the tables, graph, drawings, photographs. Make some conclusions. What did you find? Do your results support your hypothesis? What did you learn? So step 5 is actually just basically telling you to conclude. So for instance, the conclusion will be something like, as I watch my bulbs in series, I saw that the more bulbs I put in series, the dimmer it would shine. In other words, its brightness will go off. From that, I could have concluded that the current have also decreased. The resistance have decreased as the resistors increase. Okay, and then in parallel, what happened? The more I put in, the resistors placed in parallel decrease the total resistance, and as a result, the current increases. So can you see those difference? You will see it in this little table. It's very well stipulated for you. So step 5 in your experiment for your portfolio of evidence would be to explain what happened. You can even go and draw a little graph in Excel. Okay, I will show you how to draw a graph. You can put that in. You can, or Google how to draw an Excel graph. I don't want to do your whole assignment for you, but if you have a need in me showing you that, then text me. I will then make a little video for you to how to draw a graph. You can put that graph in, because isn't that what graphs is? It is showing that the evidence that we have gotten from the experiment that we've performed shows, but this is it. This is what happens. Okay, then experiment 2 is a different experiment. It's to prove the conservation of matter. Now what I'm going to do is I'm going to leave you first with experiment 1. Okay, I'm going to leave you for a couple of days. Let's first focus only on experiment 1. Experiment 2 is obviously going to be the same questions asked, but it's a different topic. Then I just want you to carry on with your assignment. It says there, remember now, we've done experiment 1 and 2. That 5.2 is still part of your portfolio. Remember, the portfolio was 5.1 to specifically aim and doing science. 5.2 is saying there are a number of reasons why practical work is done. Design a little poster or flyer to show, explain to the group why practical work is necessary. Remember, we've done a lot of those. You can make it, the practical work is necessary to think more scientifically, to make the work come alive. You can design that on Word, you can use paint, you can do whatever you like just to make it colorful, make it bright. It's basically a marketing. It's almost like you advertising the fact that we should do practical work in science. Then number 6 will just be another thing. I will go through that with you. It's going to be easy. We just have to go through it. And the same with the last parts, asking you write your overall. So what I'm asking you to do now is go and design for yourself the portfolio. Okay, it will look like this. It will say portfolio, and it will have number 1. It will have this on page 1, this on page 2, and then you will include your table of contents. Then you will start putting number 3 there. You will have number 4, and then you'll have number 5, the portfolio. And under the portfolio, you will have something that looks like this. It will start there. Remember, the top part won't be in there. So the portfolio will say this. Experiment 1 will look at that. Okay? And then you will put in your steps. You will then do as I have told you. And then you can also start designing your pamphlet. So I will come back to you within a week or so, and then we'll do experiment 2. And we will also then look at the reflection on learning and selecting of activities. So see if you can do for me that I've explained to you with the help of your notes and the pictures and the documents that I'm going to send to you on WhatsApp. Good luck.